Hi everyone, Assalamualaikum and good day. As for today, I'm Dr. Hazrina Ahmad, will be your instructor for today's topic. Right, so we have the first topic of our Mooc, which is the basics in reinforced concrete design. Okay, whereas we are going to cover the limit state design as well as the code of practice. These are our topic outline. We can see here that the first one that we will be covering is on the reinforced concrete design concept. Then we are going to proceed with the limit state design, okay, whereas we are going to look into the ultimate limit state, okay, as well as the serviceability limit state. And then we are going to look into the combination of actions. Okay, then the next topic will be on the code of practice, okay, whereas we are going to cover on the Eurocode publications, Eurocode notations, and also the Eurocode terminology. Okay, and then the last one, okay, we are going to cover on the basics of design, okay, whereas we have the design working life, design action, variable action, as well as the nominal cover. Okay guys, let's look into the first topic. Okay, we have reinforced concrete design concept. Okay, so before we start designing, okay, we need to understand, okay, on what is the design concept, okay, that we have to fulfill, okay, in order to have a proper design. Okay, so let's look into the design definition, right? So it is process of material selection and determination of element sizes of the structure to be built in consideration of the loadings that is subjected to the structure, right? So the main keyword, okay, of a design, okay, is that we have to make a selection of the material, okay, whether we wanted to use the steel design, okay, or we wanted to use the reinforced concrete design, or we are going to use the pre-stressing method. Okay, and then we have also to determine the element sizes, right? So these element sizes will be depending on the type of structure that we are going to build. Okay, and also we have to consider on the loadings, right? Okay, so these loadings are also with regards, okay, to what is the type of structure that we will be designing. Okay, so the next one, okay, what we can see here, okay, these are the main aim of design. Okay, which is the first one, okay, is to ensure that the structure is safe, okay, and then it has to fulfill its purpose, okay, it has to be strong, and the design also has to be economical, right? So these are the four important things, okay, that we have to consider in design. Okay, so the basic one, okay, that we need to bear in mind, okay, is that it has to be safe. Okay, so the next one we proceed on the material itself, right? So as for this topic, okay, we are going to look into particularly into the reinforced concrete design. Okay, so therefore we need to understand, okay, the reinforced concrete material first, right? So reinforced concrete is a composite material that combines concrete with the steel reinforcements. It is the combination of these materials that provides a strong, durable building material that could cater for both compressive and tensile stresses. Okay, right? So we have a combination, okay, of these two materials. Okay, so as what we can see here, okay, in the combination of concrete and steel, okay, we can see that the compressive stress will be catered by the concrete, which is strong in compression. So we know that concrete, okay, has the ability to cater for compression, okay, in a very good behavior, right? So in comparison to the tensile stress, right? So we know that concrete is weak in tension. So therefore, okay, in the reinforced concrete design, we are combining, okay, the steel reinforcement into the concrete in order to cater for the tensile forces. Okay, as we know, okay, the steel itself, okay, is very strong in tension and also in compression. Okay, so that is why, okay, we have this composite material to be used in the reinforced concrete design. Okay, so now let's proceed with the limit state design. Okay, so we have a few limit state design that we have to consider in the reinforced concrete design. Okay, so first we are going to look into what is limit state design. Okay, so limit state design, okay, is very important in a design process, whereas it is to achieve the acceptable probabilities that a structure will not become unfit for its intended use. Okay, so in other words, it will not reach its limit state throughout the design life of the structure. Right, so if we still remember, okay, when we look into the main aim of design, okay, we have to ensure that our structure is safe. Okay, then it has to fulfill its intended purpose. It has to be strong, and also it has to be economical. Right. So looking at this limit state design, okay, we wanted to ensure, okay, that our structure is safe, okay, for its intended use, okay, so that it can be usable, okay, for the occupants and also the end users. Right. So there are two principal types of limit states, okay, that we are going to look into in the reinforced concrete design, which are the ultimate limit state ULS and also the serviceability limit state SLS. First, we look into the ultimate limit state. Right, so this requires the structure to be able to withstand with an adequate factor of safety against collapse, designed to ensure the safety of the occupants and also the safety of the structure itself. As what you can see from the definition, okay, of the ultimate limit state, this is the main aim of our design process, whereas the key word here is safety. Right, so we wanted to ensure, okay, that our structure will not fail, okay, throughout its design life. Right, so therefore the possibility of failure, okay, such as buckling, overturning, okay, and accidental damage has to be taken into account. Right, so we do not want, okay, our structure to fail, okay, during its design life and risk the life of the occupants. Okay, so the ultimate limit state is divided into the following categories, right? So these are the categories that is actually listed in the Eurocode, right? So we have the first one, which is the loss of equilibrium of the structure, then internal failure or excessive deformation of the structure or the structure member. Okay, and then we also have the failure due to excessive deformation of the ground and also the fatigue failure of the structure or the structural member. Alright, so as we can see here, okay, with regards to these categories, we can see that we wanted to avoid any failure of the structure in consideration of the ultimate limit state. Okay, then we move on to the next one, which is on the serviceability limit state. Right, so this requires the structure to be able to serve to its intended purpose for the user or occupants under the specified service requirements. Okay, so as you can see here from the definition, it says that the main keyword here is service. Right, so we have to ensure, okay, that our structure must be able to serve to its intended purpose, right? So it has to be comfortable. It has to be felt safe, okay, by the occupants and also the end users, right? So generally, the most important serviceability limit state that we have to consider in the design, okay, are the deflection and also the cracking. Right, so with regards to the deflection, okay, it covers on the appearance of the structure or the comfort of the occupants, okay, should not be affected. Right, so even though the structure might not fail yet, okay, however, okay, if we have a structure that has excessive deflection, what happens, okay, is that the occupants will not be comfortable being in that particular building, for example. Right, okay, so this is what we wanted to avoid. Then another one is in terms of cracking. Right, okay, so we have to do the checking, okay, in terms of cracking as well in the design process in order to check, okay, whether the cracking, okay, does not affect, okay, the appearance and also the efficiency of the structure. Right, so in the design process, okay, or in the occupancy of a structure, okay, so we do not want to see cracks, okay, everywhere. Right, especially if we have excessive cracks, even though the structure has not failed yet. Right, so these are the things that we have to consider in the serviceability limit state. Okay, so the next one, okay, is the other limit state that we have to consider as well, okay, which are the durability, okay, the vibration, and also fire resistance of the structures, right? So for a reinforced concrete structure, okay, in the design of a reinforced concrete structure, the normal practice is to design for ULS, okay, whereas we are going to design for the reinforcing elements. Okay, and then we are going to check for SLS, okay, whereas we are going to consider the deflection check as well as the crack check. Okay, and then we are going to take all necessary precaution, okay, to ensure the durability of the structure. Right? Okay, so these are the steps, okay, that we are going to cover, okay, in the reinforced concrete design process. Okay, next. Okay, we are going to look into the codes of practice. So as what we all know, okay, when we talk about reinforced concrete design, we are going to refer to the codes of practice, okay, as our standard codes to find the equations, okay, as well as the values to be used in our design process. Okay, so first we are going to look into the Eurocode publications. In Malaysia, okay, the Malaysian construction industry is currently using the Eurocode as the code of practice for the reinforced concrete design, okay, replacing the British standards. Okay, so previously we are using the British standards. Okay, however, nowadays, okay, in the construction industry, we are already going to look into the Eurocode design process. Okay, why Eurocodes? Right, so as what we can see here, right, so these are the reasons, okay, why we are using the Eurocodes. Okay, so but the main thing, okay, is actually to have an economical design, okay, whereas we can save much more material in comparison, okay, to the British standards design. Right, okay, so you can read through, okay, on these reasons, okay, why we are now using the Eurocode. Okay, so now we are going to look into the Eurocode publications, right? So basically, the usage of these Eurocodes will be based on the type of structure that we are dealing with, right? So as we can see here, okay, this top part, okay, will be covering on the structural safety, serviceability, and also durability. So this will be covered by EN 1990, or it is also known as the Eurocode Not. Okay, and then in terms of the actions of structures, okay, it will be covered under EN 1991, right? So as for this EN 1991, okay, it is known as the Eurocode 1, right? So, and then we also have various Eurocodes, okay, that is used for the design and also detailing. So this will be depending on the materials, okay, that we will be using, okay, in our reinforced in our structural design. Okay, and then we also have EN 1997 and also EN 1998, right? So these are particularly for the geotechnical and also the seismic design. Okay, so these are the Eurocodes, okay, that will be used in the reinforced concrete design, okay, which is the first one, okay, which is the Eurocode Not, okay, which will be covering on the basics of structural design, okay, and then we also have the SEN 1991, okay, so this is Eurocode 1, which will be covering on the actions on structures, right? So Eurocode Not and also Eurocode 1, okay, will be used in all types of structures. Okay, and then we also have Eurocode 2, okay, which will be particularly on the design of concrete structures. Okay, so these are for the comparison, okay, between the Eurocode and also the British standards, right? So previously, okay, we are using the BS 8110, okay, which is for the basics of structural design, right? Okay, so now we are already replacing, okay, all the British standards codes, okay, with the with the BSEN. Okay, and these are other superseded standards, okay, which is referring to the British standards. Okay, so these are the Eurocode notations, right? So basically, when we talk about Eurocode notations, okay, it usually uses the subscript, okay, whereas we can see the examples here, okay, whereas we have ED, okay, which is representing the design internal effect. Okay, so as for NED, okay, so we can see that this ED here is a subscript. Okay, so this will be representing the design actual force. Okay, and then we also have RD, okay, which is the design resistance. Okay, so we can see that we have this RD written in subscript, right? Okay, so this is carrying the meaning of design resistance to the actual force, right? Okay, so throughout the Eurocode, okay, we can always see, okay, that it is using the subscript extensively. Okay, So let's now look into the difference, okay, between the Eurocode terminology with the terminology used in the British standards. Okay, what we can see from this table is the comparison between the terminology used in the Eurocode and also the terms used in the British standards. Okay, so for example, okay, the first one is actions. Okay, so actions in the British standards is known as force or impose displacement, and it is also known as loads. Okay, and then we have verification, okay, which is previously used as a check, okay, in the British standards. Okay, then we have resistance, okay, versus capacity, execution versus construction, okay, then permanent action versus dead load. Right, so this is one of the main term, okay, that is changed, okay, in the Eurocode. Okay, whereas we change the word action, okay, as well as the term of the permanent action. Okay, and then we also have variable action, okay, versus live load or imposed loads. Okay, we have already covered on the codes of practice, okay, that we will be using in the design process. So next, we are going to look into the basics in design. Okay, these are the things, okay, that we need to understand before we can actually design the reinforced concrete structure. Okay, so this is the first one, whereas we are going to look into the design working life. Right, so this design working life is given in the Eurocode not. Right, okay, so table NA1 gives us the indicative design working life that we are going to use in the design process. Right, so usually, okay, the design working life, okay, that we will be using in our design is a design working life category 4. Right, whereas the indicative design working life in years is 50. Okay, and this is suitable, okay, for building structures and other common structures, okay, that is not listed elsewhere in this table. Okay, and then as for monumental building structures, okay, highway structures or railway bridges and other civil engineering structures, usually we are going to go for the design working life category 5. Okay, whereas the indicative design working life is 120 years. Okay, so and then the next one is with regards to the design situations, right? So we have 4 design situations that we have to look into the design process. Okay, so the first one is persistent, second one is transient, okay, the third one is accidental, and also the fourth one is seismic. Right, so for persistent, it is referring to the conditions of normal use. Right, so usually in the design process, we are going to opt for persistent. Right, so this is the normal condition. Okay, and then the second one is transient. Okay, whereas this is for temporary conditions of the structure. Okay, for example, during the construction or during the repair. Alright, okay, so this is another type of design situations that we have to consider. Okay, since we are going to have different values for these design situations. Okay, and then we have accidental. Okay, so this is involving exceptional conditions of the structure or its exposure, for example, in fire, explosion, impact, and etc. Okay, and then the last one is seismic, whereas the structure is subjected to the seismic event. Right, okay, so as for this fourth one, okay, so if we are designing for our structure to be able to resist the seismic action, okay, so therefore we need to consider this design, this seismic design situation. Okay, so next we proceed with the design actions, right? So basically these are the definitions, okay, of actions that is listed in the Eurocode, right? So we have permanent actions, okay, which is usually noted by G, okay, and then we also have variable actions Q, okay, and also the accidental actions. Right, so now we look into the definition of each of these actions. Right, so these actions is a set of applied forces, okay, or loads for which a structure is to be designed. Right, so we have to look into the function of the structure. Okay, then we are going to determine what are the loads, okay, or what are the actions that is subjected to that particular building, right, or for that particular structure. Right, so for example, if we are designing for a school structure, for example, okay, so we have to consider, okay, the partitions between the walls, okay, and then we also have to consider, okay, the students, okay, in the structure and so on. right? So, and differently, okay, if you are designing for a bridge structure, for example, okay, therefore we have to consider the traffic loads, right? Okay, so this is where, okay, we are going to consider all the actions, okay, that is acting on that particular structure in consideration, okay, of the function, okay, of that particular structure, okay, to be designed. Okay, alright, so now we are going to look into the design actions, okay, terms in particular, right? So the first one is the permanent action, okay, so it is the actions, okay, which are normally constant throughout the structure's life, right? So it will not change, okay, throughout the structure's life, okay, which includes the weight of the structure itself and also all the static components, okay. So for example, okay, the self-weight of all permanent structures. For example, we have the beams, okay, self-weight of the beams, self-weight of the slabs, okay, self-weight of the walls, and so on. Right? So it will not change throughout the design life of the structure unless it is hacked. Right? Okay, and then we also have the variable actions. Okay, so as for these variable actions, usually the notation is Q. Right? So these actions are more difficult to determine accurately. Okay, because when we talk about variable actions, okay, it is known as the live load, okay, or the imposed load, okay, that will always change, okay, throughout the design life, right? So estimates are based on design on standard codes of practice or past experiences, right? And the values adopted are based on observations and also measurements, right? So it is less accurate in comparison to the permanent actions, right? So for example, the weight of the building occupants, right? So if you are designing for a school, for example, right? So we are going to have students that come and go, right? Okay, so therefore we are going to have moving load here, right? Okay, so this is considered as the variable actions. Okay, then we also have furnitures, okay, and also removable machineries. So all these are considered as the variable actions. Okay, and then we also have another type of action, okay, which is the accidental action. Okay, so these are unexpected loadings, okay, which are not easily foreseen, right? Okay, so this is unexpected ones lah. Okay, right? So basically, okay, in the design process, we are going to design, okay, with regards to the permanent actions and also the variable actions first. Okay, right. So this is the variable actions. Okay, basically how we are going to determine the values from the Eurocode. Right, so it is given in the MSEN 1991, okay, which is the Eurocode 1, okay, and it is also referring to the national annex that is particularly for Malaysia. Right, okay, so we have table NA2, okay, which gives us the categories for residential, social, commercial, and administration areas, including additional subcategories as for the Malaysian structures. Right, okay, so as what we can see here from this table NA2, okay, we have the category of the loaded area. Right, so whenever we wanted to determine the variable actions, okay, we need to know what is the function of that particular area, right? Okay, so and then we have the second column, which gives us the specific use, okay, which have the areas. These are the examples. Okay, what we can see here, we have areas for domestic and residential activities, office areas, areas where people may congregate, okay, and so on. Right, okay, so we have to choose, okay, the type of this specific use, okay, in order to have the estimation of this variable actions. Okay, and then referring to those category of use, right? Okay, we are going to determine the category that is involved, okay, as well as for these codings, right? So we have A1, we have A2, A3, and so on, okay, which is referring back, okay, to the previous one, okay, so from the previous slide, okay, and then we are going to be able to, okay, to determine the values of QK, okay, here, right, which is in kilonewton per meter square, right? So this is the estimation, okay, of the value of loads we are going to get for our variable action. Okay, so this is on the combinations of actions, right? So in the Eurocode, okay, it is stated here, okay, that we have a few combination of actions depending on whether we are designing for the ultimate limit state or we are designing for the serviceability limit state. Okay, so this is a table, okay, which is table 2.15, which gives us the sets of A, B, and C, okay, for the partial factor of safety for actions, right? So basically, when we talk about the combination of actions, okay, we are going to look into the permanent and variable actions, okay, that will occur in different combinations, considering the most critical design situation for any structure, all right? So in particular, for the reinforced concrete design, we are going to consider the design of reinforcements under the ultimate limit state. Okay, whereas the partial factor of safety that will be considered is 1.35 for the permanent action, and then 1.5 for the variable action. Okay, so this will be the last one, okay, for this topic, right, which is on the nominal cover. So basically, this nominal cover will be depending on the exposure conditions, okay, whereas it is the chemical and physical conditions in which the structure is exposed. In the design process, these conditions are considered to ensure the durability of the reinforced concrete structure, okay, by the provision of the nominal covers, right? So basically, this nominal cover is to protect, okay, the steel reinforcements, okay, from the environmental effects. Right, so this is table 4.1, which gives us the exposure classes, okay, in relation to the environmental conditions. Okay, so we can see that we have the class designations. Okay, so we have X0, we have XC1, XC2, and so on. Okay, which is based on the description of the environment. Okay, so we have no risk of corrosion or attack. Okay, then we have corrosion induced by carbonation and so on. Right, okay, so this is the table, okay, that is in the Eurocode 2, okay, which has to be referred to in order to determine whether we require a thick nominal cover or not. And as for the nominal cover, okay, so this is the equation that we will be using, okay, which is stated in the Eurocode 2. Right, so we have C nominal, which is equals to the C minimum plus with C deviation. Okay, whereas the C minimum, okay, should be set to satisfy these requirements. Okay, so we have the safe transmission of bond forces, okay, the durability, and also the fire resistance. Okay, as what we can see from this figure, right? Okay, so we are going to consider the cover to the reinforcement, okay, which is to be covering the link as well as the reinforcement, right? Okay, so this is where, okay, the cover will be. Okay, and this is the clause, okay, that is given in the Eurocode 2, okay, with regards to the nominal cover. Okay, so the concrete cover is the distance between the surface of the reinforcement, okay, closest to the nearest concrete surface, including the links and stirrups, and surface reinforcement where relevant, and the nearest concrete. Right, so this is the equation that I've mentioned in the previous slide. Okay, and we are going to determine, okay, the C minimum, okay, based on this equation 4.2. Okay, whereas C minimum is the maximum, okay, between the C minimum bond, okay, C minimum durability, as well as this minimum value of 10 millimeters. Right, so we are going to also consider the fire resistance requirement. Okay, so what we can see from this figure here is the spacer block, okay, that can be provided on site, okay, in order to provide this covers, right? So after we have already calculated and designed the nominal cover, okay, for our structure, okay, then we are going to provide, okay, the spacer blocks, which is made out of mortar, okay, with the same grade of concrete that we will be using for our structure, okay, and it will be tied up to our reinforcement. Okay, so this will be embedded inside the concrete of our structure. Okay, so these are the tables, okay, that we will be considering in the determination of the nominal covers, right? Okay, so we have the minimum cover with regards to bond, right? Whereas we are going to consider the arrangement of bars, whether it is separated or bundled. Okay, so therefore the minimum cover for C minimum bond, okay, will be based on the diameter of the bar. And then we also have table 4.4n, which gives us the values of minimum cover, okay, with regards to the durability. Right, as for this one, okay, we are going to refer to the exposure class, okay, that I've mentioned before, in the previous slide, okay, whereas we are going to look into the conditions of exposure that our structure is exposed to, and then we are going to determine the class designation, okay, as well as for the structural class, right? So as for the structural class, it will be basically based on the design life of our structure, right? And then what is given here is the C minimum value in millimeters. Okay, and then this is another one. Okay, this is the last one, whereas we are going to look into the fire resistance as well, right? So this table is basically based on the requirements of fire resistance, okay, and also the requirements of the duration of fire resistance, okay. So it is given in minutes, right? Okay, we have R30, R60, and also up to 240 minutes. Okay, and this will be based on the type of structure that we are considering. Okay, whether we are considering a simply supported beam, okay, a continuous beam, or it is a slab. Right, and based on this, okay, we are going to look into the minimum width, okay, of these components. Okay, and then we are going to determine what is the value of C minimum, okay, that we have to provide for our structure. Okay, so this will be the last one, okay, for this topic on the basics of design, right? So then the next one, we are going to proceed with other topics as well for our MOOC. Okay, so with that, thank you very much for listening. Thank you.